it comes to measuring frequency, we have a couple different units. The first, most obvious, is if we measure frequency in revolutions per second. The units for that are going to be revolutions per second, but here's the thing. The revolutions part is understood. So often, we can just write the units as 1/seconds. And what's a 1/second? That's right, it's been renamed after Heinrich Hertz. So we use the abbreviation HZ. Hertz. Yeah, you've heard of Hertz. You've heard of Hertz. Good. So what's an RPM? RPM is also a measurement of frequency. One of the travesties in the United States is the way we sometimes write out our formulas, leading to confusion. Why did we do that? I think it's to keep us down, but that's another story. Miles per hour. How do we write that on a speed limit sign? How do we write that? 65, what is it? Miles per hour. You lose the meaning. Do you know what they write in Canada? Well, they do it in kilometers. But they write it as kilometers per hour. Revolutions per minute is a measurement of frequency because it's the number of revolutions per unit time, which in this case is a minute. Easy. Now, can't believe I'm going to bother to do a demonstration for this, except that it includes my table saw. And anytime I can use an old table saw in class, I want to do that. Now, I have my table saw, which runs at 3,600 RPMs, so 3,600 revolutions per minute. What would the frequency for that be? Revolutions per minute, 60 seconds in a minute, 60 hertz. You're right. Nice. Now that's when it's running at 120 volts. But if I hook it up to my variac, which is essentially like a variable resistor for alternating current, I can adjust the voltage, which will adjust the rate that the saw is spinning and thus change its frequency. Now, if we take a quick look at that, I'm going to start it off kind of slow and see if we can see that moving. You can, can't you? Good. And how does it look? Looks kind of blurry, doesn't it? Do you know why? Because it's spinning fast enough that the light that is reflecting off of that into the camera and thus to your eye is hitting it at different points in the rotation. And that image then becomes blurry. I don't even think I need to explain that. I think you already get it. So you know what I can do? I can hit it with a stroboscope. And let's see what happens. All right, so here's what I'm going to do. I'm going to get this spinning at a certain frequency. And if I can match that frequency with the stroboscope, I can thus measure the frequency of the table saw. Let's do that. But first, I got to hit the lights. Now, the most important or dangerous part of this demonstration is making it back over here without crashing. Oh, I love that sound. But now, if I get the frequency of the strobe light to be exactly in tune with the saw, I can get that letter A to stand still. Now, obviously, it's not standing still. Go ahead. Mason, go put your tongue on that. No, I'm just kidding, Mason Pendexter. Don't do that. That would hurt. But while it appears to be sitting still, it's actually still moving. And when I looked at the number on that stroboscope, it said that it was at 19.2 hertz. And if I were to hit that with my finger, that would hurt so good. No, that would be bad. Even John Cougar Mellencamp wouldn't like that. So, the stroboscope allows us to measure the frequency. This is what they do when they're testing the timing belt in your car. in order to adjust it, they use a strobe light. Yeah, they do. And then they fine-tune it so that it's going to be going at just the right frequency. Now, if I increase the voltage, I can get that up a little bit higher. Oh, it's a little bit dark in here. I'll cut this out later. But if I hit it with the strobe light, geez, it is really dark. And I hit it just right. I can get that to stand perfectly still. Right now it's at almost 30 hertz. So in a moment we'll calculate what that frequency would be in revolutions per minute. You know what? While I'm at it, let me show you another thing. I have this extension cord. It's a fancy one. It's got a little LED in the end. And that LED is flashing at 60 hertz. And if you look closely at it, you can sort of tell that maybe there's a bit of a flash to it, but it looks pretty much like one continuous emitting light. But if I set it into motion, let's see what happens. See if we can capture this. Now, instead of a strobe light giving us that effect,